Hello, my friends. Today, I want to share a story with you. A true story, a scientific one, but also a haunting one. One careless moment, and history held its breath. Wow. A fateful beginning. It was August 21st, 1945. At the Los Alamos laboratory, the most secretive place on Earth at the time, a young physicist named Harry Daghlian was conducting a risky experiment. His goal was simple: to see how neutrons would behave around a core of plutonium-239 when surrounded by different materials. That day, Harry was using blocks of tungsten carbide, an ultra-hard substance, also known as wolfram carbon. The experiment looked almost harmless, like stacking bricks. One block at a time, he placed the dense material around the plutonium core. And then, the neutron detector began to click. The clicking grew louder. The readings climbed rapidly. Warnings filled the air. But Harry didn't stop. He reached for one last block, and in an instant, the detector screamed, louder than ever. Startled, Harry tried to swipe the blocks away with his hand, but it was too late. One block fell, landing directly on the plutonium core. A chain reaction began. A blue flash filled the room, the color of death, the glow of a supercritical nuclear event. 25 days later, Harry Daghlian died, killed by radiation exposure. He became the first person in history to die from a nuclear accident. Chapter: How fission works. But how? How could a single block trigger something so powerful? It all comes down to nuclear fission. In simple terms, fission happens when a neutron strikes the nucleus of an atom, like uranium-235 or plutonium-239. The atom splits, it releases energy, and more neutrons. Those neutrons go on to hit other atoms, and so begins a chain reaction. But for that reaction to sustain itself, it must reach what's called criticality. That means the number of neutrons created equals the number that escape or are absorbed. Scientists measure this using something called the neutron multiplication factor, or K. If K equals 1, the reaction is stable. If K1, it dies out. But if K1, it escalates, fast and dangerously. In Harry's case, the core became supercritical in a split second because too many neutrons were reflected back into the plutonium. 3. The reflectors, silent killers. These reflectors, materials that bounce neutrons back into the core, are absolutely critical. They don't just reflect, they trap the neutrons and give them another chance to cause fission. To do this well, a reflector must have low neutron absorption, high heat resistance, and a good molecular structure for reflection. Take a look. Beryllium has very low neutron absorption, just 0.009 barns. Pure carbon is even better, only 0.035 barns, but it can't handle high heat. Tungsten? Not ideal, 4 to 10 barns, but incredibly heat resistant. In Harry's test, that tungsten carbide, the material that seemed safe, reflected enough neutrons back into the core to cause a catastrophic reaction. 4. But where did the neutrons come from? Here's a mystery. There was no external neutron source in the experiment. So how did the reaction even start? The answer is spontaneous fission. Plutonium-239 doesn't need help. Even on its own, it emits 40 to 50 neutrons per second, per kilogram. Harry was working with over 6 kilograms. That's more than 250 neutrons per second. With strong reflectors around it, those neutrons didn't escape. They bounced, they stayed, and in one tragic moment, they ignited the chain, just one block, placed wrong. That's all it took. 5. Slotin's turn, the second death. Less than a year later, another scientist, Louis Slotin, attempted a similar test. This time, the reflector was beryllium, and instead of using machines, Slotin held the two halves of the beryllium shell apart by hand, using nothing more than a screwdriver. On May 21, 1946, the screwdriver slipped. The two halves came together, sealed the core, and once again, the room flashed blue. Slotin, in a split second, ripped the reflectors apart, saving everyone else in the room, but not himself. 9 days later, Louis Slotin died. His final words? "It feels like there's metal in my mouth." Fact. The fate of the Demon Core. After the two fatal accidents, that plutonium core earned a name: the Demon Core. It was scheduled for detonation during a nuclear test in Bikini Atoll, but the Pu-240 content was too high, too unstable, too dangerous. Eventually, the Demon Core was melted down and repurposed, or so they say. Some reports claim it was tested anyway, but the detonation failed. Others believe the truth was buried, along with the core itself. We may never know what really happened. Final thoughts. The price of knowledge. This isn't just a story about nuclear physics. It's a warning. When humans become too confident, when curiosity outpaces caution, the line between discovery and disaster becomes razor thin. Knowledge is power, but it's also a blade. It can enlighten, but it can also kill in a flash. If this story made you pause, if it left you thinking, like, share, subscribe. And join me next time as we uncover more hidden truths and the deadly science that lies in the shadows.